Okay, so in the last class, if you guys remember, we talked about ellipse, we talked about foci, what are the properties of foci, how do you find out um, the foci if you have, no, we did not do that. We figured out if you have the equation how, of a ellipse given to you, how do you find out the center and the minor and major radius from it, correct? Does everybody remember it or still? I'm sorry, beta? Yes. So let's, okay, here we shall.
Hi, sir.
Okay, so in the last class we were talking about ellipse. Ellipse, as we speak, is nothing but a distorted form of a circle, correct? In circle you have only one radius, and that is how your equation is x minus h squared plus y minus k squared equal to r squared, where h and k are the x and y coordinates of the center, correct? And r is the radius. When you are talking about ellipse, ellipse is nothing but a distorted form of a circle, meaning when you squeeze the circle from the top or from the side in a symmetric way, you come across an ellipse. And when you are talking about ellipse, it doesn't have a common radius. It ends up having two radiuses. One is called the major radius, I will call it A, and one is called the minor radius, that is called B. Okay? And it doesn't necessarily have to be like this. My ellipse can be rotated with a 90-degree angle also, where the major radius is along the y-axis and the minor radius is along the x-axis in this case. But here, the simplest form that you see, your major radius is along the x-axis and minor radius is along the y-axis. And the equation for the ellipse is x minus a, x minus h squared by a squared plus y minus k squared by b squared equals 2, 1. So instead of r as one common radius for a circle, here you have two radiuses, one is major radius, one is minor radius, and this is the equation for the ellipse. Up to this much you guys recall? Davik, Akshaya, Vishal, Dev, Samriddhi, Arush, everybody? Akshaya, you recall beta? Yeah. Now, so in the previous class what we did was, we looked at certain examples where the equation was given and we had to find out the major and minor radiuses. Here x minus h by a squared, this a squared is the radius along the x-axis, be it a minor radius or major radius, no bias. We will not say that a is the major radius and b is the minor radius. We will say a is the radius along the x-axis because it's the denominator of x part, and b is the radius along the y-axis because it's the denominator of the y part of the equation. Yeah. And then we looked at one concept called foci, where foci is nothing but, it's one of the property of an ellipse which says foci are the focus points, are 2 points along the major radius, where this point and this point are equidistant from the center, as well as here. I mean, obviously, if this distance and this distance are same, this distance and this distance will also be the same because this whole thing is same, correct? So foci are the 2 points along the major radius such that it says any point on the perimeter of the ellipse, this distance and this distance will be same, or sum of this distance plus this distance will be equal to, let's say if this is my focus, this is my focal length, this length from the origin to here, I will call it a focal length. Here to here I will call this a focal length. These two will be the same. So what it says is if this is a point taken on the perimeter, from first focus point or the focal point to this distance, and from this to this distance, if you add them up, if you add these two distance, this will be always the same, and it will be equal to sum of 2 times the major radius. And again, I'm repeating, I think I muffled my sentence a little bit. So here, foci are the 2 points along the major radius such that these 2 points are equidistant from the origin, and any point you pick up along the perimeter, sum of this distance plus this distance will be always the same. Be it here, be it here, be it here. If you are taking this point, so this here to here the distance, and here to here this distance, this sum of these two distance will be equal to sum of these two distance, will be equal to sum of these two distance as well. And that will be equal to 2 times the major radius. Do you guys remember it, or is this a okay review? Akshaya, and if you guys want me to repeat, I don't mind, it's okay. Akshaya, are you able to recall it better?
Yeah.
Don't have to be shy with me, okay? I have no shame in acknowledging that I am the least intelligent teacher. So if any of my kids says that I did not understand, that is primarily because of me. I could not explain it better. Okay? So let's keep this concept for now. And we also looked at how is sum of this distance and this distance equal to 2a. We just picked up an extreme point here to here this distance, plus here to here this distance. Sum of these two were equal to 2a. That's what we saw, right? I mean, you can see this. This distance and this distance are same. Here to here is 2a. You have this distance plus this distance. Sorry, if you are taking this point, this distance plus this distance, the total distance from this point, from this foci, and this distance and this distance are equal, so this adds up to become 2a. So this is the concept part of it. Let's look at some more problems, or let's look at one more concept before we start jumping into the problem part of it. And if some of the things are not clear, don't worry, I have a habit of repeating myself so much so that you will have no issue recalling it. Everybody can see the board, okay? Okay. So this is ellipse. Believe me, this is an ellipse. It doesn't look like an ellipse, but let's say this is my major axis. This is my major axis, and this is my minor axis. Meaning here to here is my major radius A, here to here is my minor radius B. And as we saw, if these are 2 points called focus points or foci, this is F1, I mean let's say this is point P1 and this is point P2. This length I will call as focal length. I will call it F as in focal length, meaning the distance from the origin to the focus point, and this distance will be the same. Up to this much is okay? Now let's try to find out the relationship between the focal length and the 2 radiuses that we are aware of, the minor and major radius. Let's pick up any point here. Okay? So what the foci says is sum of this distance plus this distance. If this is d1 and this is d2, d1 plus d2 is equal to 2 times the major radius. This is the property. Yeah? Is this okay so far? Now, other thing that you can see here is, let's find out the relationship between the focus point and the minor and major radius. If you, let's say if I pick up this point, let's not pick this one. I'm picking up this point. So that way it's easy to relate to A and B. If I'm picking up this point, so this distance plus this distance will be equal to, so D1 plus D2 is equal to 2A, or D1 is equal to D2 is equal to A. Is that making sense so far? This plus this is equal to 2A, and here I have picked up a point here at the center, meaning along the minor axis. So that means I am picking up a symmetric point. So this distance and this distance will be the same. So that's why I am saying this D1 is equal to D2 is equal to A. Is that okay to believe so far? Acha, you're not giving me that confidence. I'm sorry, Beta?
Understand it better.
Yeah. No, so I mean, see, I'm not trying to put anybody on the spot, but I just need the confidence to come from you guys, okay? So that I can continue, okay? So now I have picked up this point, okay? My goal is to find out the relationship between this focal length and the minor and major radius, okay? That's what we are trying to do. So I picked up this point here, which is right along the minor axis. So this distance and this will be the same because I have picked up a symmetric point. So D1 will be equal to D2 will be equal to A. Now look at this triangle alone. This triangle which I have shaded just now. It's nothing but a right angle triangle, correct? So if I am calling this as D1, which is nothing but my hypotenuse of this right angle triangle. So that means D1 square will be equal to this focal length, this square plus this square, which is nothing but B square. Yeah. This is what one of my uncle named Pythagoras told us, right? As per the Pythagorean theorem, in a right angle triangle, hypotenuse square is this square plus this square. So I have just put it here. Now we just saw that if I am picking up this point, my D1 is equal to D2 is equal to A. So I will replace D1 with A. So it becomes A square will be equal to F square plus B square, or F square will be equal to A square and B square comes to this side will be equal to A square minus B square. Does it make sense? So if you ever know what is your major radius and what is your minor radius, you should be able to find out what will be the length of the focus or the focal point from the origin, or what will the distance between the origin and the focus point, or the one of the foci. Make sense? And this is what we saw. So again, just to repeat, we picked up a point here along the minor radius and we said, okay, fine. As per the definition of the foci, it says that these 2 points which are called foci have a property that any point you pick up on the perimeter of the ellipse, sum of this distance will be same as 2A. Since I have picked up a symmetric point, so this one D1 and D2 will be the same. So D1 plus D2 will be equal to 2D1 or 2D2, which will be equal to 2A. That means D1 or D2 will be equal to A, or the major radius. So we found one relationship here, and we put that by picking up this as one right angle triangle. And so we said, okay, fine, if this is my D1, which is my hypotenuse of this right angle triangle, D1 square will be equal to this square, F square plus B square. That means, and D1 is my A, so from that we form this relationship. So the focal point or the focal length of an ellipse is equal to, square of the focal length is equal to square of the minor radius minus the square of the major. Sorry, it's reverse. Focal length, square of the focal length is equal to square of major radius minus the square of the minor radius. Is that clear to everybody, including me?
Yeah.
Don't sound confident, but if you guys don't sound confident, I'll be less confident. Do you want me to explain one more time, better? No? Arush, clear? Dev, clear? Okay. So, all right. So let's move on then. Okay. We'll see. If we come across a hurdle, we'll deal with it. Now let's look at some problems and see how we are able to apply these concepts for solving these problems. How do we get rid of the problem that is coming our way? So let's pick up one of the questions. Now we are given, see, this is a visual problem that we are dealing with. This is a coordinate plane 1, 2, 4, 8, 12, 4, minus 4, minus 8, minus 12, minus 16. Are you being bothered by mosquitoes? Come to the first row, beta. Come to first row. You have your defense in place. Okay. And then you have 4, 8, 12. Sit as close as possible to this machine. That will give you the defense. And this is 1, 2, 3, 4. I'm trying my best to draw it, okay? Even if I don't do a great job, I'll give you the information that you would need for being able to solve it. Okay. So let me give you guys some information. Okay. This is the center, which is minus 4, minus 3. Okay. I know this doesn't look like an ellipse, but what to do? My drawing skills are not going to improve big time. So we have 3 points given to us: minus 4, comma 2 as the one of the vertex of this ellipse along the minor radius. Another vertex here is 9, comma minus 3 along the major radius, and the center is given as minus 4, comma minus 3. And we have been asked to plot the foci of this ellipse or find out the coordinates of the foci of the ellipse. How would you go about it? Again, let me repeat this. So this is the ellipse. Forget about the, okay, let me do a better job, slightly better job without putting much effort. Just forget about where the coordinate plane is, okay? You have 3 points. Center is given as minus 4, comma minus 3. Along the major radius, this vertex is given as 9, comma minus 3. And along this one, along the minor radius or minor axis, this vertex is given as minus 4, comma 2. You have been asked to find out the foci of this ellipse. I'll give you guys 2 minutes to think about it. Everybody heard the question, right? See, this problem seems to be difficult. I'm already sweating. I'm just kidding. I'm not sweating because of the problem, it's because of the humidity. So here, this is the ellipse. We just know the coordinate of this point and we know the coordinate of this point, which are the vertex along the minor and major radiuses. and we are given the coordinates at the center also. From this, you have been asked to find out the coordinates of the foci, meaning there are 2 points, one is here, one is here. We have to find out the coordinates of this guy and coordinates of this guy. How would you approach this? Any thoughts? Just give me the approach. Don't try solving it.
Wait, I have a question.
Yes, beta.
So, is like the Focii like can it be in the middle or like anywhere?
So foci is like, you can imagine foci as 2 symmetric points along the major radius, okay, which will be equidistant, meaning from here to here this distance will be equal to this distance.
But what I'm asking, like, you know, the major distance, like, you have to solve for the thing, or like, is it like in the middle? Or,
It's not in the middle. It's not that you will take these 2 points, find out the distance and divide by 2. It's not going to be that way. It will be somewhere such that it follows this. Okay, I'm giving you guys the clue. F square is equal to a square minus b square, meaning this focal length, square of that will be equal to square of the major radius minus square of the minor radius. So from that you can find this distance. If you find this distance, you'll be able to find out the coordinates. Yeah? So same distance you will take on this side and find out the coordinates. Does it make sense, beta?
yeah.
Yeah? Okay, let me solve this first, okay? Without giving you guys too much of thing to worry about. So if I look at this thing, right? When I am looking at this problem. First thing is, okay, we have been asked to find out the foci, or the coordinates of the foci. And we will recall, okay, what is the foci for us? Foci are the 2 points which is equidistant from the origin. So this distance here and this distance here will be the same. Now, what is this distance? This is what we learned, right? We also know that, okay, foci means any point you pick up on the perimeter, add these two distance, sum of these two, if this is d1, this is d2, sum of these two is equal to 2 times the major radius. Okay, but this information is not needed right now. I mean, this is just to recollect. Now when I see this one, okay, so this distance f square is equal to a square minus b square. Do I know a square? Do I know the length of the major radius? Yeah, I can see the length of the major radius, correct? This is my major radius and this is my minor radius. From here to here, my y coordinates are same. This is along the x-axis, right? I mean in the direction of the x-axis. So this from here to here, what is my distance? It's only my x coordinate that is changing. Y coordinate remains the same. So the distance, the distance between this point and this point is x coordinate of the later point minus x coordinate of the initial point. This becomes 9 minus into minus plus 9 plus 4, that is 13. So we got this length as 13 units. Does it make sense? Now here to here, same way. My x coordinates are same. This is parallel to the y axis. So what is this length? That is the difference between the final point minus the initial point of the y coordinate. So 2 minus initial point, this. So 2 minus into minus plus, that is 5 units. So my minor radius is 5, major radius is 13. Are you guys with me? Yeah? Akshay also? Okay. Yeah, I'm just checking availability. Okay. So now from this we found my minor radius is the distance between 2 and minus 3, which is 5, and my length around the major radius, the length of the major radius is distance between minus 4 and 9. Only my x-axis distance has changed. The distance along the x-axis only has, the coordinates only along the x-axis has changed. So that is minus 4 to 9. So we have traveled 13 units. So my major radius A is 13, my minor radius is 5. So what will be the focal length? F square will be a square minus b square. And if you guys know that Pythagorean triplets, 5, 12 and 13 is one of the triplets. But if you don't want to recall that, just put it here. So focal length will be equal to a square, 13 square is 169, minus b square, 5 square is 25. So f square is equal to 144. That means f is equal to square root of 144, which is 12. So this distance from here to here is 12, meaning this is changing by 12. So if you add 12 to minus 4, what will be the change in your x coordinate? That will be 4 minus 4 plus 12 will be 8. So x coordinate became 8. Y coordinate doesn't change because this is a straight line parallel to the x-axis. So my y coordinate is not changing any which way. So first one is 8 minus 3. How about this one? Here to here will be 12. So let's say this is x. X plus this one plus, okay, this is going in this direction, right? So it's, you're moving 12 points from here. So minus 4 and going 12 in the negative direction. So minus 4 and minus 12. That will be minus 16. So your x coordinate will change to minus 16. Y coordinates anyway doesn't change. It remains minus 3. Did I make decent sense to everybody? Is it relatable? Everybody? Okay. Akshaya, Davik, Vishal. Yeah? Okay. I will let you guys practice one problem now. So, in summary, I mean, without even worrying about the complexity of the problem or worrying about how old I am, without worrying about what we will have for dinner. If we are talking about ellipse, there are the 3 things that we need to keep in mind. One is, my ellipse's standard formula is x minus h square by a square plus y minus k square by b square equal to 1. This is my standard formula. Foci, with respect to foci, we saw that f square equal to a square minus b square, where a is my major radius, b is my minor radius, and this f is nothing but the focal length, meaning distance between the origin and the one of the foci. Okay. And the third thing you'll remember is this picture of the ellipse, which says this is a major radius, this is a minor radius. Foci are the 2 points along the major radius or major axis, such that any point you pick up along the perimeter, the sum of these 2 distances will be always the same, which will be equal to 2 times the major radius. As long as these 3 things stays in our mind, we should be fine. And this is a derived formula. Okay, we don't have to remember this. This is a derived formula. But then you'll have to do that circus that I was doing, right? But okay, if you know this thing, then how about the focal length, this length or this length? You'll have to pick up this point and then visualize this, which will give you help to derive this formula. So it's up to you how you want to keep that in your random access memory RAM. Yep. Is everybody clear so far? Let's pick up another problem. You're still okay. So for Davik has the same problem in the classroom. Mosquitoes keep chasing him. So I have ordered one more of this one, and I'll get you guys wristbands, okay, which is like a mosquito repellents. Okay. So everybody in the classroom will get a mosquito repellent band before the class starts, so that in the evening class you guys are not bothered about this one. And if it is still bothering you guys, what I would suggest is, if you have there are some ointments, right, which you apply for as a mosquito repellent, just use that, so that way you don't get bothered by mosquitoes. Yeah. All right. Somehow they are very friendly with me. They don't bother me. They know that I'm paying the EMI of this house. Anyways, let's move on. Let's pick up another problem. Okay. let me pick up another problem. And this time also I will not try doing the stunt of mapping it with the coordinate plane. This is my minor radius or minor axis, and this is my major axis. So here to here my minor radius is A this time, and my major radius is B. Okay, the coordinates are given as 0, 0, and this coordinate is given as -3, 5, and this origin's coordinates are given as 3, 0. Sorry, -3, 0. Okay. So in this ellipse that you see, your origin is at -3, 0. The coordinates of one of the vertex along the minor radius is 0, 0, and this one is -3, 5. So you can visualize that your coordinate plane is here. Okay, if I draw the ellipse and then I try mapping the coordinate plane, then I do a better job. So now you have the ellipse. You have been asked to find out the foci of the coordinates of the two foci of this ellipse, and I'll let you guys struggle with this. Does that sound like a plan?
What did you say we are finding?
The coordinates of the two foci, like
What?
the two foci, the focus points. Is that clear, Vishal?
Yeah.
Yeah. I mean, whatever we did in the previous example, we are just going to repeat that thing with a different example. And this time I want you guys to struggle with this. Samriddhi, Dev, Akshaya, Davik, everybody clear what we are trying to do? Are you clear, Akshaya, beta? You have not confirmed, so I'm just curious.
Oh yeah.
Yeah, okay. So just, I'm sorry if I'm calling your name again and again, okay? I just need a confirmation that everybody has understood what we're trying to do, okay? So just respond to me on time, so that way I will not bug you, okay? Okay. So deal with it for next 2-3 minutes before I start opening my mouth. Do one thing. I will do house arrest for you and mosquito both. Because the garage will remain open, there will be more coming in. You can hold your feet and I'll take care of this. You focus on the map, okay? Knock off the yes. Okay, any luck, anybody? Yes, Akshaya.
I thought the focal length is 4.
Focal length is 4, okay? You are in the right direction. Tell me the coordinates also better.
Oh, I didn't do that.
Okay. And that will be an easy one. You have done the difficult part. Yes, Davik.
I'm confused because the length of A is 3 and the length of B is 5.
Uh-huh.
And if f squared equals to a squared minus b squared, that means you're doing 9 minus 25.
No, so I see again that's why I was saying that I don't have a definition of A and B. A is the length along the x-axis or radius along the x-axis. B is the radius along the y-axis. When I'm comparing, when I'm visualizing that with respect to the equation of a ellipse. But when it comes to the focal length is always along the major radius. So here in this case, if your B is the major radius, the formula will change from a square minus b square to b square minus a square.
Okay, and then it's 4.
It's 4. Now you help me find out the coordinates of the two foci.
Yeah, I'm gonna figure that out now.
Alright. Akshay, you're clear, right? You got me the first part right. Now it's a easier part. Okay. How about Samriddhi, Dev, and Vishal?
I'm a little bit confused.
I'm sorry, beta?
I'm a little bit confused.
Okay. So
Yeah, I'm confused too.
okay. So that okay. How about Arush? Close or done?
Close.
Close. Okay. Yes, Davik.
Is it negative 3, 4 and negative 3, negative 4?
You said negative 3, 4 and negative 3, negative 4. If I said you're wrong, would you have the courage to fight with me? Fight as in not the feast fight. I'm talking about the fight with argument. No, you're right, brother. I was just pulling it right.
Okay.
Yeah. Okay. No, so see, I'm just trying to instill that confidence in you all. Okay. It's about there's nothing fancy about this. Let me break it down. Everybody, okay? So Vishal, Dev, Samriddhi, Akshay, Davik, Arush, everybody, including myself. All the problems that we are doing now or we will do in future is going to revolve around 3 key facts. First is ellipse. My ellipse is nothing but a squeezed form of a circle. And when I look at this equation, this h and k are the x and y coordinates of my center or origin of the ellipse. Okay? And h is the radius along the x-axis and b is the radius along the y-axis. I will not say a is my major radius or b is my minor radius. I will just say whichever is bigger is my major radius, whichever is smaller, that is my minor radius. If my ellipse is like this, then b is my major radius because that is the radius along the y-axis. If it is horizontal, then this is my major radius. That's fine. Samriddhi, Vishal, Dev, everybody, right? Yeah? So this is my first thing. Now, what is a foci? Foci is a one unique behavior or unique property of a ellipse, which says foci are 2 points along the major radius always along the major radius. Okay. So if this is lying upside down, it's like vertically, then this is along the y-axis or the axis parallel to the y-axis. If it is lying horizontally, this is along the x-axis. But this foci has a property that these are 2 points equidistant from the origin. So one point will be this distance is same as this distance, always. If my foci is here, then this distance and this distance will be the same. Okay? Yeah? So that is the second point. So if this distance and this distance are same, then obviously this distance and this distance will be the same. Correct? And foci says, there are two things about foci. One is they are same distance from the origin, and any point you pick up along the perimeter of the ellipse, be it this point, 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 any point. From the foci to that point, this distance, one foci, second foci, or focus point, whatever you call it, okay? This distance plus this distance, if you add them, if this is d1 and this is d2, when you add them, when you add both of them, both the distances, meaning the distance of that point from one focal point and the second focal point, sum of that will always be 2 times the major radius. Here my major radius is b, so I will say, okay, this is b. Okay? Is everybody with me so far? And this distance, the focal distance, meaning from the origin to the one of the foci, this distance will be equal to square of this distance will be equal to square of the major radius. Here my major radius is b square minus the major radius. Okay? And this one we saw by picking up this point and then seeing this distance, we related that and we found the relationship between A, B and the focal length. Yeah? Is that clear, Dev and Samriti?
Yes.
Yeah? So here, in this case, we were given, yes Dev, you have to be louder, beta.
So the focal point is only on like the major.
Always, 5 times always along the major axis only. Yeah?
Okay, thank you.
So here, in this case, the situation that we were dealing with was that we were given the coordinates of the origin of this ellipse, which that is minus 3, 0. And one of the vertex which is along the major radius was given as 0, 0. And another vertex along the major radius was given as minus 3, 5. So here, see your x coordinates are matching. So this is a line parallel to the y-axis. Minus 3, minus 3. So the length from here to here will be the distance between here and here, which is 5 units. So that became your major radius, 5. How about the minor radius? Minor radius, one point is minus 3, 0, other point is 0, 0. Your y coordinates are not changing. Your total length is the distance between minus 3 and 0, which will be again 3. Obviously, this will be your major radius. 5 is your major radius. This is a minor radius. What will be the focal length? Square of this will be square of major radius minus square of minor radius. 5 times 5, 25, minus 3 times 3 is 9. 25 minus 9 gives you 16. So square of the focal length is equal to 16. So focal length will be square root of 16, which is nothing but 4. Yeah? So you got this focal length as 4. Again, this is line parallel to this one. So here, your only thing that is, your x coordinates are not changing, your only y coordinates are changing. So your x coordinate will remain the same. Here and here both, minus 3. From here to here, your length is 4. So y is changing from 0 to 4. That becomes minus 4 because you are going the negative direction on the third quadrant. Here to here, x coordinate remains the same, y coordinate changes from 0 to 4. That is how this length is 4 and this length is 4. Did this make sense to everybody? Yeah? Dev? Acha? Yeah? So once you find out the focal length, then finding out the coordinates is like, is all based on how you visualize that in the coordinate plane, right? I mean, if you know the length and you know that one of the coordinates, second coordinate you can always find. Yeah? Is the problem still not solved? The mosquito problem? Okay, now. Okay, I have ordered one more. I will probably cover you guys with this one and then get you. The bands are going to be delivered tomorrow. Okay. All right. Is everybody clear? Let's look at another problem. Now, this problem is reverse of what we were doing so far. This is more of a mathematical problem than anything else. So you are just hear this question out from me loud and clear, and then we'll see what to do with this. The question says the equation of an ellipse is given below. That is x plus 8 squared plus y plus 9 squared, and this is x plus 8 squared by 169 and y plus 9 squared by 25 equal to 1. What are the foci of this ellipse? Meaning you have to find out the coordinates of the two foci, and here are the options given to you also. We will see what you want to solve by solving versus without solving. This is 1 and second one is 4 comma minus 9. Second one is given as minus 8 comma minus 29 and minus 8 comma 11. Third one option is given as 8 comma 29 and 8 comma minus 11. Fourth one is given as 28 comma 9 and minus 12 comma 9. Okay. So this is the equation given. Yeah.
Is it no answer?
Yeah. I mean, if you know the answer, which one?
I think it's B.
You think it's B? I'll come to you to pick your brain. Okay, so I'm just reading the question from last time and then I'll let you guys deal with it. So we have an equation given for the ellipse and we have been asked to find out the coordinates of the foci. And there are the four options given. I got one answer from Arush and I'll not tell you guys what it is. If you heard it, good. If you did not, even better. And I want you guys to apply all possible tricks or methods to solve it in the least possible time. Everybody got the question right? Samriddhi, Dev, Akshaya, Vishal and Derek.
I just came back from the bathroom. Can you explain the question?
So this is the equation given to us. X plus 8 squared by 169 plus y plus 9 squared by 25 equal to 1. This is the equation of the ellipse given to us. And we have to find out the foci, the coordinates of the foci, and there are the four options given to us. Minus 20 comma 9, minus 9 and 4 comma minus 9. Minus 8 comma minus 25 and minus 8 comma 11. 8 comma 29 and 8 comma minus 11. 28 comma 9 and minus 12 comma 9. So you have to pick one and I will let you guys figure out how you want to solve it. Any trick, good or bad, up to you. Everybody got the question right? You guys want me to stay quiet for 2 minutes? Okay, let me have a quick chit chat with Arush in the meantime. Closing the garage door helped, I think, right?
Yeah.
Closing it helped. Yeah. Okay. So tell me, go for it. Yes, Davik, you got the answer already?
Give me a second.
Okay, sure. Yeah, Dev,
I think I got A.
you got A. Okay. Akshaya, Vishal, and Samriddhi. Yeah.
I'm still working on it.
Okay. Yeah. And don't even believe what Dave said or what Aru said, okay? You find your own solution. Friends are not always trustworthy. I'm just kidding. Okay. Yeah. What did you do? What is the focus in here?
So you went on the longer one, which is this one, and so you just right, whatever. Then we do the x axis
The middle is
plus 8, which is minus 8, because part of it is negative, which puts you right here, negative 8 line. And then long x is x of negative 8 is b, and that's b. But then, you do your math, because longer side minus short side, square is square.
Third.
12, and it's also okay. But it's not so many notes. I think it's B.
No, but you see.
Is equal to 12.
So see, whatever from here minus 8 and minus 9 that you got, that is the coordinates of the origin, not the coordinates. Okay, so the origin here, and from there you have to figure out which way you are going to change your coordinates. Okay. Anybody being ready? Daivik, Vishal, you also got a. How about Akshaya, Samriddhi, and Vishal?
My sister was like talking to me, so I had to.
She is already a victim of what I do on Saturday and Sunday. She must be wondering what you are doing with me on a Wednesday.
No, she didn't know I was in class, so.
Okay.
Do you want me to I got it really fast.
I'm just waiting for other kids also to just tell me their thought process actually. Okay. We have 4 more minutes. I'll give 1 more minute to everybody else, then 1 minute to whoever has got the answer to explain, and then I will do my stunt with this problem. Yeah, Akshaya, you had unmuted yourself, beta. Are you saying something?
I don't really sure how to solve it. I did the Pythagorean a little bit, but
Okay.
I didn't get I got different numbers.
No worries, beta. We'll deal with it together. Don't worry. Okay. Vishal and Samriddhi.
Oh, I'm a little bit confused.
Okay.
I get part of it, but then I don't get the other part.
Okay. So Davik, can you explain what you did, and Dave, how did you get to A?
So I looked at H and K, and they gave me 8, 9 for the center, and then I eliminated everything else because well, no, not every. Hold on. Let me look at my notebook.
Okay. Dave, what was your thought process behind getting to A?
The way I did it is I first look at both of the denominators and I see the A value is bigger, so I know the X values are going to change, so I eliminated B and C. So after that I'm only left with A and D, and I just calculated 169's square root at that step, and I got 12. So, and I just did the X value plus 12 and I got A. Plus minus 12.
Okay. So now we have only 2 minutes. I'll probably stretch the class by 2 minutes more, okay? So when I had this problem, okay, I wish I could do that without solving it, but let me not try doing that for now. From this one we are trying to find out what all information we have. When I see this equation, this is my equation for the ellipse. This is the denominator of x term, this is a square, this denominator of y term, this is b square. So this is a square is 169, that means a is 13. And b square is 25, that means b is 5 square, which is b is 5. Yeah. So we got the major radius is 13, minor radius is 5. Now when I look at the numerator here, x minus h square, y minus k square, my h and k are positive. That means my h value is minus 8 and k value is minus 9. This is my coordinates for the origin or the center of the ellipse. Okay, and since I am seeing my a radius, the major radius is a part, so I am visualizing this as lying horizontally. Okay, so this is my center, which is minus 8 comma minus 9. I am essentially in the third quadrant. Yeah.
Okay. Alright.
Yeah.
It's A.
Okay.
I mixed up something.
That's okay. So you guys see it, right?
Wait.
So far it's clear. We found a and b from the equation. We found the coordinates of the origin or the center of the ellipse, which is minus 8 comma minus 9. Now we know what is my focal length. Focal length is a square minus b square. I don't care about a and b. I know focal length square is major radius square minus minor radius square. So major radius square is 169 minus major radius square is 25. So f square is 144. That is focal length is 12. 12 square is 144. So we got the focal length as 12, meaning from here to here I have to move by 12 points, and from here to here I have to move by 12 points. So again I am moving along the x-axis only, right? Because that's my major radius. That's my major radius. So this here, when I am adding 12 to it, minus 8 plus 12 gets me to 4 comma minus 9. So this one is 4 comma minus 9. My y coordinates are not changing. Only x coordinate increased by 12. So when you increase by 12 along the number line from minus 8, it goes to plus 4. When I decrease by 12, it goes from minus 8 to minus 8 minus 12, that is minus 20. And my y coordinate doesn't change. So that is how it will be this one. Did it make sense? A little bit. A little bit. Some scope for negotiation. Akshaya, Dev, Vishal, everybody.
Okay, so what's the answer?
I'm sorry, what?
What's the answer?
A.
Oh,
So basically, now if you look at how we decoded this, right? We first looked at this equation. From that we found out a and b, and that gave us a very clear view that a is my major radius and b is my minor radius. That means it is horizontally aligned. And from this we found that the coordinates of the center is minus 8 comma minus 9. As soon as we found that, we found out what is the value of my focal length, which is 12. So I am moving by 12 from minus 8 minus 9, this side and this side both. When I go 12 from minus 8, it becomes 4 comma minus 9. When I go 12 from minus 8 along the negative side, it becomes minus 8 minus 12, that is minus 20. So that is how it came down to this one. Yeah? Make sense, everybody? Akshaya, Dev, Vishal, everybody?
yeah.
Yeah. So I said we'll take 2 minutes extra, and I was spot on with my estimation. So what I'll do is, once I upload the video of the class, I'll send you guys the link for the unit test also from Khan Academy. Try breaking your head with some problems. It is not as difficult. It's all about how you decode this. Okay. As long as you are clear about the equation, as long as from that you can derive what is your major minor radius, how you derive your focal length. After that, it's just about scratching it on a piece of paper, making a rough sketch with my level of skill of drawing, which is not great in any which way. Then you should be able to find it very easily. Yeah. With that being said, I'll let you guys go. Have a good night rest, good dinner, and see you guys soon. Alright?
Thank you.
Yeah, alright. Bye bye.
Thank you.
Bye bye. Bye bye. Bye beta.